Finding slope on a graph. All right, so in order to find the slope ratio on a graph, again, we have to always remember that slope is represented by our vertical change, which is our change in y, and how it relates, or how it, what's the right word? How it compares to the change in x. So the first thing that you have to be able to do on a graph in order to do this correctly is to be able to identify lattice points that are integers, which are positive whole or negative numbers, okay? Whole numbers. And the reason is because it makes it easier to identify these slopes. So that being said, a lattice point is any corner of one of these little squares. Whoops. So like here, this is lattice point, this is lattice point, this is all these little square dots, the corners of the squares are lattice points. And if we want to find the slope of this line, we have to look for lattice points that fall on this line. So for instance, this right here, oops, not that, just kidding, is a lattice point. And the reason is you can see in green that it's the exact corner of this little grid square, yeah, part of this grid, okay? And then another lattice point is right here. So those aren't the only two. There are definitely probably more, but since those are the first two I see, that's what I'm going to use to find my slope. So my change in y, remember my y-axis runs vertically, so I want to make sure that I get up to this point, and I'm going to, if you guys remember from when we did the skateboard activity, we're going to count the spaces in between. 1, 2, 3, 4. And the direction we were going is up, which is positive. And so for our change in y, we would put 4. And then our change in x, which is our horizontal change, is 1, 2, 3, 4, 5, 6. And it's to the right, so it's positive. Now, as you can see, this slope can be simplified. 4, 6 is the same as going up 4 into the right 6 is the same as doing up 2 into the right 3 2 times, because they're both divisible by 2. So to check to make sure we did this right, we should be able to go back and make sure that our slope ends up being 2/3 consistently all the way up and down. So see, every 2 I go up, I go over 1, 2, 3, and I land on another lattice point. Up 2 over 3, up 2 over 3. So you can see I'm landing on every lattice point. That's possible. Now you can see right here, my line's not very straight, so it doesn't work on this one. So for the second example, you can see I've already identified 2 lattice points that fall on this line. So again, I want to remember that slope is the vertical change, or the change in y, in comparison to the horizontal change, or the change in x. So it doesn't matter which point I start on. Let's say I start down here on this one, okay? And I'm going to go 1, 2, 3, 4, 5, 6 points up. And since I'm moving up, that's a positive direction. So that's my change in y. And now to get to this blue point, the other lattice point, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And since I'm moving to the left, that's becoming more negative. So it'll be to -8. And you can see that that gives me a slope of 6 to -8. And just like on the last example, I can simplify this. If I divide by 2, you're going to see that if I started on either of these points, for every 3 points that I move up or down, I'm going to move either left or right 4 horizontally. So in gray, you'll see that happen. If I move up 3, 1, 2, 3, and then I go over to the left 4, 1, 2, 3, 4, you can tell that my line's not very straight because it should have crossed through that lattice point. Unfortunately, Educreations doesn't give you the access to making a straight line, or I just don't know what I'm doing. Okay, so then again, I should be able to go up another 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4, which I do, to land on that other lattice point. Okay, and again, I should be able to go in the opposite direction too. So if I go 1, 2, 3, 4, 1, 2, 3, you can see I land on the line. It's not a perfect lattice point, but I'm still landing on that line. So even though you may not land on the lattice point every time, the slope should still lead you to a constant rate of change that will always land on the line. All right. Now, this one's a little bit different. Go ahead and see if you can place your own 2 lattice points. And you're going to notice that the lattice points here, there's quite a few of them. Okay? And it doesn't matter how close you put them. So if I want to do this lattice point and this one, it doesn't matter where I put them. I'm still going to look for my change in y and my change in x. Now, what you should notice is that if I start on one of these points, to get to my next point, I'm not going to move up or down. I have no change in y. So to represent that, what means nothing? Well, our favorite number is 0. Makes math easier. Okay? And then if I want to get to this other point over here, you're going to see that I'm going to move 2 spaces to the right, which makes it a positive 2. And in any case, you're going to see 0 divided by any number is 0. So your slope is going to equal 0. And that will be on any horizontal line that you ever draw. And if you think about what slope is, this line has no vertical movement whatsoever. If you're going downhill skiing, this would be 0 fun because it's a horizontal line. You got tricked, you're really going cross-country skiing. All right, and this one last example is unique in itself as well, because you're going to notice that this line is completely vertical, and there's a ton of lattice points on here as well. Okay, so when you pick 2 of them, doesn't matter which 2, it's still going to be the change in y over the change in x. And in this instance, let's say I go up 1, 2, 3, and my change is 3. And then you'll notice that there is no horizontal movement, so it's 0. And we cannot divide by 0. So in this instance, anytime you have a vertical line, because there's no horizontal movement, this slope is undefined. Undefined. All right, and that's how you find the slope of a line from a graph.